All right, today we are going to talk about long division problem that doesn't give us a whole number quotient and expressing remainders in decimal form. Basically, this is how are we going to decipher between decimals that go on forever and decimals that terminate, i.e. terminating decimals. And for those of you that saw the most recent Super Bowl, the new Terminator is coming out soon. So we now have a new Terminator reference. I'll be back. All right, so this brings us to, we have had terminating decimals before in an earlier lesson. Those are decimals that stop. For example, 4.5, and then they don't stop. A repeating decimal is one that goes on forever and doesn't stop, or or it repeats after a while. So let's take a look at the differences between those and how maybe we can decipher how we do those. All right, so let's take a look at the differences between a terminating and repeating decimal. When we were talking about fractions, we talked about the fact that we can turn a fraction into a division problem by dividing the numerator and denominator, or dividing the numerator by the denominator, and that turned it into a decimal, and that we would get either a terminating decimal, which stopped, and had no remainder, or that we would get a number that either repeated a set pattern. For example, 40 over 72 would give us 0.5 repeating right here. Whoops. Sorry, 0.55555 or 0.5 repeating with that little bar notation over the top, which would be a repeating decimal, which means it would always get a 5 when we divide it out because it's going to repeat forever. Now, what we are going to do is we are going to take and look at whether or not we're going to look at two different fractions. We're going to take a look at these four fractions and really quickly talk about whether or not they are going to be a terminating or repeating decimal and why. It basically boils down to whether or not this third bullet right here is very important. Can we turn them in their denominator into a factor or equivalent fraction over a power of 10? So if I can take their denominator and either turn it into a factor of a power of 10 or a multiple of a power of 10. Powers of 10 are 10, hundreds, thousand, a million, something like that. Then it will be a terminating decimal. If you can't turn it into a power of 10, chances are it's going to be a repeating decimal. So let's take a look at this. Let's take a look at A. A says 6/15. Okay, now 6/15 has 6 and 15 share a common factor of 3. I can reduce both of these by 3. If I reduce 6 by 3, meaning I divide it by 3, I get 2. If I divide 15 by 3, I get 5. And 2/5, if I multiply this by 2 and this by 2, I now have 4 over 10, which is 4/10, which equals 0.4. Another way of doing this, I'm going to come over here to this side, is I'm going to start with 6 over 15. If I divide this out, 6 and 15 goes on the outside, we're going to add a decimal and a 0. We bring up the decimal. 15 can go into 60 4 times. We get that 6/0 down here, and we get a terminating decimal. Okay, that's one way of doing it. The other way, obviously, if we come down here, we're going to take 6 and 22, because you're thinking 22. Well, that's got 2's, we can turn that, we can divide it by 11. Well, we can't divide 6 by 11. So let's take a look at 6 over 22 now. Okay, 6 and 22, they both share 2 as a factor, which means we can reduce it by 2. Okay, so we're going to divide both of those by 2, and that gives us 3 over 11. Now, this is what I was talking about. We can't divide 6 by 11 and get a smaller number. See, that's that common factor conversation. So we get 3 divided by 11. So we're going to come over here to the other side of the screen, and we are going to divide 3 by 11. Okay, so I'm going to add a decimal and 0, and we're going to bring the decimal up, and 11 can go into 30 2 times. Okay, and that gives us 22. So we subtract, and we get an 8. Okay, and we're going to add another 0 and bring it down. All right, and 11 can go into 80 7 times, and that gives us 77. And then we subtract, and we get a 3. Of course, we need to do this properly. So we're going to add another 0. See, this is the part where, okay, I get a 30. Now, right here, I'm going to bring out my highlighter real quick. Right here, well, let's do it in blue. Right here, I can start seeing that I have a 30 here, and I started up here with a 3 and a 0. So my next number, my remainder, should be an 8. All right? So let's go back to the pen real quick. We're going to extend out my line a little farther. 11 can go into 30 2 times. Okay, 2 times 11 is 22. We subtract. I'm left with an 8 again. Okay, so we add a 0, bring it down. All right, this is where we make that decision. All right, the next number is going to be a 7. This 2 and 7, okay, this 2 and 7 right here, it is going to go on forever. That is going to repeat forever. So the answer, this problem right here, 6/22, is going to go on. That is going to be a repeating decimal. So we're going to go ahead and put the line over all of it, even though we only really need to have, so the line over the part that repeats. So 6/22 equals 0.27 repeating. All right, and the same works for when you do decimals, okay? You would work it the same way we did decimal division. Remember that fractions and decimals are just both ways of showing parts of a whole. Thank you.